To summarize geometric sequences from Unit 7, Lesson 2, we're going to give you a crazy monkey game where you earn points for eating bananas, and each banana you eat is worth 3 times as much as the last one was. We'll say you get 1 point by just starting the game. So in this table that we need to complete, when I'm just starting and have eaten no bananas, I will have 1 point. The first banana, to keep our geometric pattern going, we'll take this times 3, will be worth 3 points. The next banana I eat will be worth 3 times as much as the last banana. So 3 times 3 makes 9. Of course, we have our multiplication pattern going on here because it's geometric. Then my third banana, it'll be worth 3 times as many points as the second banana was. So 9 times 3 makes 27. Again, 27 times 3 makes 81. So I can finish the table and know my fourth banana will be worth 81 points. What type of sequence is this? Well, being that we're reviewing geometric sequences, it's geometric, but why is that? Because we are multiplying by 3. It's a multiplication. Bad verbiage there, but anyways, each term is a multiplication of the last term by 3. We need a recursive formula. So now they want us to use p sub b plus 1 and p sub b. So the b plus 1 is going to be the next banana. So we'll start with that. My next banana will be worth points equal to 3 times p sub b, the banana I just ate. Remember, recursive formulas always need a starting. So we're going to say p sub 0 equals 1. That's when we first start the game. For our formula function, or function formula, this is the one where we want our table to work. If we plug in 1, we want to get 3. And again, my best recommendation is that if you try a formula, you make sure that if you plug in 1, you get 3. You plug in 2, you get 9. So let's try. We want p of b to be equal to. Now remember, this is growing really quickly, and you may have discussed it, that it's an exponential relationship. It's not a steady linear growth like arithmetic was. So we're going to have our beginning number, 1, times our rate of multiplying each time to the b. Now let's see if this works. You might have seen a formula like this already. Let's see if we plug in. If I put in 1 for 1 banana in for b, 3 to the first power is 3, times 1 does make 3. Let's put in 3 bananas. 3 to the third power is 3 times 3 times 3, which makes 27. 27 times 1 makes 27. This formula is working for every number in our table. If I plug in the number of bananas at the top of the table, I get the number of points that are indicated in the bottom of the table. Always check your formula to make sure that it is working. So now, since I know it worked for my table, if I want the 8th banana, I can just plug in 8 into my function equation. So 1 times 3 to the 8th will give me my 8th banana, which equals 6561. That means when I eat the 8th banana, that banana will be worth 6,561 points. Now, magically over here, I have this formula I want to show you real quick. And again, it doesn't matter what formula you use when it comes to function formulas for either arithmetic or geometric, but you need to make sure that your table actually works with it. This won't happen a lot, but let's say someone says, man, my first banana was worth 3 points. The general formula for geometric is your beginning number times your rate to the n. That's your general equation. So if you were going to say my beginning banana, my first banana was worth 3 points, and times your rate of 3 multiplying each time to the b minus 1, check this out. So if you put in 3 bananas, I'm going to eat 3 bananas. If I put 3 in for that b, 3 take away 1 is 2. 3 squared then would be 9, and 9 times 3 would be 27, and that's what I want. This formula over here will work, but we probably don't really use this b minus 1 a lot. I wanted you to see that because they do mention a couple different things about what term you start with. So again, our beginning term in the original equation works just fine. And honestly, either one of these equations is great. As long as what you plug in from the table gives you the output you want, both equations are correct.